We'll see the signals and systems question from gate 2009. So here given that the Fourier series of a real periodic function has only cosine terms if it is even, sine terms if it is even, cosine terms if it is odd, sine terms if it is odd. So which of the above statements are correct? So out of the given statements, the PQRS, the sine terms if it is even, and cosine terms if it is even, and sine terms if it is odd, both are correct, and sine terms if it is even is wrong, and cosine terms if it is odd is wrong. So here the answer is A. Now we'll see the solution for this. So coming to the solution. So here it is. Let us consider trigonometric Fourier series. So we have the trigonometric Fourier series f of t equals to a naught plus summation n equals to 0 to infinity an cos n omega naught t plus bn sin n omega naught t. Here a naught equals to 1 by t naught integral over t naught f of t dt, and an equals to 2 by t naught integral t naught f of t into cos n omega naught t dt, and b naught, and b naught equals to bn equals to 2 by t naught integral over t naught f of t into sin n omega naught t dt. So here considering that the statement P, that is if cosine terms if it is even, let us consider the f of t. F of t is even. Then if f of t is even, considering that a naught here, so f of t is even, we know that the integral of even term is always having some finite value, and this f of t is even here, and cos n omega naught t is also even. The product of even term and even term becomes even itself. Then we'll get the integral of some even term becomes some finite value. Coming to the bn here. So here f of t is even, sin n omega naught t is odd, so the multiplication of even and odd both becomes odd term, so the integration of odd term is always 0. Then we have only a naught and an term, and b naught becomes 0 here. Bn becomes 0 here. Then coming to the trigonometric Fourier series, we have a naught dc term, and the cosine terms, the quotient is an, but there is no sine terms. Then the statement q, the statement p is correct. The statement p is correct here. Coming to the last statement. Coming to the last statement, that is given it as sine terms if it is odd. Sine terms if it is odd. So let us consider that f of t is let us consider that f of t is odd here. So if f of t is odd, then we have a naught equals to the integral of odd term. Let us consider a naught, that is 1 by t naught integral f of t dt, that is equals to integral of odd terms becomes 0 here, and an equals to 2 by t naught integral over t naught f of t into cos n omega naught t dt. See here f of t is odd and sine term is even, then the multiplication becomes odd itself. The multiplication of the integration of odd term becomes 0 here. And coming to the bn, that is 2 by t naught integral t naught f of t into sine n omega naught t dt. So f of t is odd and sine term is odd. The multiplication of odd term with odd term again becomes even term. So the integration of even term becomes some finite value. So we have a naught equals to 0 and an equals to 0. We have only the bn term. Then in the trigonometric Fourier series, a naught 0, an 0, we have only bn, nothing but we have only the sine terms in the Fourier series. So we have only sine terms in the Fourier series. Sine terms only in Fourier series when f of t is odd. Then the statements p is already correct here, and yes is correct. So out of the given statements, we have p is correct and yes is correct, and this is wrong and this is also wrong. So we have option A is the answer.